Hello everybody, my name's Mr. Ray Ray. Today we're going to be talking about alternate angles. Now, alternate angles are a way to solve for unknown angles using parallel lines. Now the shape that we're going to be looking out for whenever we're dealing with alternate angles is a Z or an N. Now the important thing to remember about alternate angles is we need parallel lines. The parallel lines in question are going to be the arms of the Z or the legs of the N. So as long as I have a pair of parallel lines, I can work with alternate angles. Now, the principle of alternate angles is that they are equal. Which means, in the corner of the Z, if this angle is 60 degrees, it means on the other side, the other corner of the Z, that angle will also be 60 degrees. The same principle will hold true if you're looking at it as an N. In the corner, we will have, say, 50 degrees. And because I have parallel lines, alternate angles tells me that this other angle in the corner will also be 50 degrees. Now, this doesn't just apply to a basic N or Z, and more often than not you're going to be given an example that is slightly more complicated. So let's say these lines are parallel. And if they tell me this angle is 60 degrees, I can use my parallel lines and my rules of alternate angles to find out what its alternate angle is equal to. So if I have a look here, would you agree it forms a nice Z here? Now the arm of each Z is a line segment of the parallel line. So using that, I can make the assumption that this angle and this angle are the same because of alternate angles. Now, in a similar way, if this angle is 120 degrees, I can use alternate angles to find out what this angle is. If we have a look at it, we have a backwards stretched out Z. Shape of the Z doesn't matter. As long as we can discern a Z shape, we can use alternate angles. Now again, the arms of the Z, here and here, are line segments of the parallel line. Which means, if this side's 120, this angle will also be 120. So we can use alternate angles as a principle to find the value of angles. However, in any straight line geometry, we need to provide proof of that statement. So if I'm given an example like so, and I'm told that these lines are parallel, this angle is 110 degrees, and I'm asked to find x. With any diagram with parallel lines, you're going to be given the name of the lines. I realize it just looks like letters scattered at the end of lines, but what it actually is, directions. So if I talk about AB, I'm talking about the line that connects A and B. If I'm talking about EF, I'm talking about the line that connects E and F. We need to know how to name lines because it's part of our proof of things being correct. So when we're doing straight line geometry, we always need statement and reason. So, in this instance, I've been given 110 degrees. I've been given x. Do I have a z in question? Yes, I do. I have a backwards elongated z. So finding the shape, not quite enough. Let's check. Are the arms of the z parallel? Yes, they are line segments of our two parallel lines, which means the statement we can make is that x will be equal to 110 degrees. That's my statement. My reason, my proof for why this is true, we will say alternate angles. And you can abbreviate to alt and draw a little angle. Saves you some time. So that's my first reason. But I need to prove that it's a set of alternate angles. For that we have to go back to our principles of alternate angles. We need parallel lines on the arms of the z. So would you agree the parallel lines in question would be AB and CD? So we will say AB, line AB, is parallel to line CD. And our symbol for parallel, two diagonal lines next to each other. So in summary, x is equal to 110 degrees because of alternate angles, and the parallel lines in question, AB is parallel to CD. We would then move on to any additional variables that we need to find. So let's have a look at a couple of examples here. First one we're given. We have a very obvious Z shape. We have X and 60. Now if we look at our shape, we can see quite clearly the obvious Z shape, which means that the 60 is the alternate angle to X. We just need to double check our proof. Are the arms of the Z parallel? Yes, they are. Therefore, we can use alternate angles. So my statement would be X is equal to 60 degrees because alternate angles are the same. My reason, I used alternate angles. And finally the proof, I need my parallel lines. The parallel lines I used were AB and CD. AB was parallel to CD. That's it, done. 3 marks. Let's have a look at another. Now, this is when it starts to get a little bit more complicated. It's intimidating when you look at anything where the shape you're looking for is not immediately obvious. But let's say these lines are parallel. And from that I can start trying to work out what type of angle I can use. So let's start by looking at X. Would you agree? If I have a look at it from that perspective, I have what's basically an elongated backwards N. Are the legs of it parallel? Yes, they are. Which means that X and 65 are alternate angles. So my statement would be X is equal to 65 degrees. My reason, alternate angles, and the parallel lines I used were the lines CD, EF. CD parallel to EF. Now let's talk about Y. Again, if I look carefully, I can see a stretched out N over here. So instead of it being an N like so, it's an N stretched out. Are the arms of this N parallel? Yes, they are, which means Y and 115 are alternate angles. So my statement would be Y is equal to 65 degrees. My reason for that, alternate angles, and I need the parallel lines that I used. So it was the same set of parallel lines, CD parallel to EF. One final example. Now, I've got multiple variables to work with. Do I need to necessarily work with them in alphabetical order? Absolutely not. You work with the ones that you can see most clearly first. So, don't know about the rest of you, I quite clearly see a Z here, which makes my life very easy. So, C and 50 would be alternate angles if the arms of the Z are parallel. Well, we've got parallel lines on the arms of the Z, perfect. Which means that C and 50 are alternate angles. So my statement would be C is equal to 50 degrees. And my reason for that, alternate angles. Now, which parallel lines did I use? AB was the top arm, CD, which you can just see there, CD was the bottom line. So, alternate angles, and it was because AB was parallel to CD. Which means that C is going to be 50 degrees here. Now, let's have a look at A. Would you agree I've got a backwards stretched out Z here? The arms of the Z, they are part of the parallel line, so we can say that 130 and A are alternate angles. So A would be 130 degrees. My statement, therefore, A is equal to 130 degrees. My reason, alternate angles are equal. And which parallel lines did I use? I used line AB and line CD. So I need to say AB parallel to CD. Now finally, let's have a look at B. If I look carefully, I have a stretched out N here, which means that B and 130 are also alternate angles. Are the arms or legs of the N parallel? Yes. Those two arrows mean they're parallel to each other. So the statement I can make, B is equal to 130 degrees because of alternate angles. And which parallel lines did I use? Well, I used these two parallel lines. Now, it doesn't matter if you say line FE or EF. It still refers to the same line that connects those two letters. However, it's generally good practice to do in alphabetical order, just to prevent yourself getting confused. So it was because line EF is parallel to GH. Okay. So, coming up now there are going to be a few examples for you to try yourself. Pause the video, try them yourself, and an explanation will follow after each one. Good luck. Let's have a look at how these should have been done. So the first step, as always with straight line geometry, I need statement, I need reason. I can never forget reason. So, first things first, can I discern a shape I can use for alternate angles? Well, absolutely, there's a nice Z here, a nice textbook Z, which means that X and 65 are alternate angles. So X and 65 are alternate angles. My statement, therefore, X will be equal to 65 degrees. My reason, alternate angles. And which lines did we use to prove this? Well, we used AB, part of AB, and part of CD. So, the parallel lines I used, AB parallel to CD. AB parallel to CD. That's how we would have approached question 1. So, question 2. As always, I need statement and reason. So I'm going to draw my little table for statement and reason. Statement, reason. Now we've got a pair of parallel lines here, and it allows me to quite easily see backwards n, which means that X and 75 are alternate angles because CD is parallel to EF. Therefore my arms of my sideways Z or my backwards N, however you want to view it, are parallel. Meaning that 75 and X are alternate angles. My statement, therefore, X is equal to 75 degrees. My reason, alternate angles. And the parallel lines I used to make this happen were because CD is parallel to EF. CD parallel to EF. That's how we would approach question 2. Now let's have a look at question 3. Always need to start with our statement and reason. So draw my little table for statement and reason. So, we've got 2 variables here, and as I've said before, it really doesn't matter which one we start with. Whichever one leaps out at you, that's the one you start with, as long as you ensure that you answer every question. So, if I have a look here, would you agree I've got a nice Z shape here, showing me that 80 and Y are going to be alternate angles. Let's double check the arms of the Z, yes, AB is parallel to CD. Therefore, I can make the statement that 80 degrees and Y are alternate angles. Statement, therefore, Y will be equal to 80 degrees, and my reason, alternate angles. As always, we need our proof, which parallel lines we use to make this happen, AB being parallel to CD. So we've dealt with Y. Let's have a look at X. Here we have a nice backwards Z. The arms of the Z are line segments of AB and CD, which are parallel. We can use alternate angles. So 100 and X can be said to be alternate angles. My statement therefore will be X is equal to 100 degrees. because of alternate angles, and it's because line AB is parallel to CD. That's how we would approach question 3. Now, question 4. First things first, as always, statement, reason. We have multiple variables, and as I've said before, it doesn't matter which one you start with, as long as you do them all. First thing I spot, a nice backward Z here, with 105 and X. Are the arms of the Z parallel? Well, yes, line GH is parallel to IJ. So we can say that 105 and X are alternate angles. My statement, therefore, X will be equal to 105 degrees. My reason, alternate angles. And the parallel lines that made it happen are GH being parallel to IJ. Next up, with Z, would you agree it's the corner of a nice Z, which is appropriate, the arms of it being parallel, GH parallel to IJ. So we can say that Z is the alternate of 75. So if Z is the alternate of 75, we can say Z is equal to 75 degrees because of alternate angles. And the parallel lines I used were GH being parallel to IJ. GH parallel to IJ. Now lastly, Y is a little bit of a challenge, because it doesn't really have an alternate angle that gives me a number like X and Z did. But if I have a look, would you agree I have a nice N over here? And the arms of the N are parallel, because KL is parallel to MN. So the arms of the N are parallel, but that just shows me that Y and X are alternate angles. Does this help me? Well, happily yes, because we'd worked out what X was earlier. So we can say that X and Y are alternate angles. So we're going to have two statements. Because Y and X are alternate angles, Y is equal to X. Therefore, so for therefore you do 3 dots, Y is equal to 105 degrees. And the alternate angle reason, we need our parallel lines, which was KL parallel to MN. Parallel to MN. Now, we don't need to put any additional reasons for why X is 105, because we already dealt with that in our first section here. Now there's the way you would need to approach question 4. So everyone, I hope this has been helpful and informative. If there is anything that's unclear, there are different platforms through which you can contact me. Please, just if you're going to email, subject line. If you're going to send a WhatsApp, just make sure that the first line is what topic we're looking at. The quicker I can review the particular video you're questioning, the sooner I can get back to you with an answer. Have a great day, study hard, and take care.